Welcome to the GOTO Podcast. In this episode, software architect Lee Atchison covers best practices around architecting and operating for scale, including risk management, moving to microservices, and continuous versus future releases. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events, held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Good afternoon, Lee. Before I introduce you and get all the details, just for those of us who are not familiar with me, my name's Ken Gavranovic. Entrepreneur, startup, did everything from founding a company called Interland, still around, called web.com, to driving transformation at Cox. Worked very closely at New Relic with Lee, where I ran product and engineering. And today I'm at a company called Uncork that actually helps enterprises move faster. So happy to be here with you, Lee, and talk about it. But just for people who don't know you, maybe just give us a little quick background.
Hey, Ken, it's great to see you again. Ken and I have been good friends. We've been working at New Relic on many projects over the course of a couple of years now, I think. Anyway, my name's Lee Atchison. I'm a consultant. I'm an author. I'm a entrepreneur as well. I own my own company called Atchison Technology. I worked at Amazon.com and AWS for about 7 years. I built the Elastic Beanstalk service, and I also built the software download store for the software and video game group at the time. And so if you've downloaded anything from the App Store, you're using generations beyond what I started with, but what I initially got started within Amazon. And then I spent another 7 years in New Relic, which is where I met Ken, and working on analytics and observability platforms and systems as well.
Great. Well, I'm really excited for our interview. Let's dig into it. Architecting for Scale. You've now got the second edition out, right?
That's correct. I always love talking to you about these topics, or frankly, any topic.
Yeah, no, I always have some great conversations. I think the thing that's always interesting to me about somebody that takes the time to write a book is, what's the first thing that inspired you? Like, there was a time you're like, hey, I've got this thing I'm seeing as a problem and I want to share my view with the world. Tell me what originally inspired you to start writing Architecting for Scale.
Sure. Yeah. So, I worked at Amazon for many years. And I learned a lot about building scalable systems there. And when I left Amazon, I moved to what at the time was a relatively small startup called New Relic, which is, there were maybe 100 total people in the company, or a little bit less than 100 people. And they were just running into a lot of the scaling problems of trying to grow from being a small system to being a much larger system. And I saw them struggle with the same sorts of things that we had already solved at Amazon. And so I kind of became the scalability expert, if you will, and helped them with putting in processes and procedures and things like risk management matrices and things like service tiers and all those different processes to help them get to the point where they can start managing their systems and scale them without having availability outages. So when I did that, then I realized that New Relic wasn't unique. There was nothing special about the problems they were running into. That all companies of probably the similar size were running into similar sorts of problems. And that's when I decided, I bet you there's a book here. I bet you I could write this into a book. And so I got connected with O'Reilly and suggested that book, and they were really excited about the idea. And I kind of went from there. So first version came out in 2016, and based on my experiences with helping get New Relic through the initial push. And then basically what happened is as the book started growing in popularity, I started getting interactions with lots of other companies, and I'd often get comments like, oh, you should hear what we ran into, and here's the problems we ran into, and those sorts of problems. And I started seeing the breadth of companies and the problems they've had with scalability in general. And a lot of that learning I fed into the second edition of the book, which came out about a year ago now.
That makes sense. I know we had some fun times, really talking with a lot of enterprises across the globe at New Relic, because you think about transformation. It's always people, process, and technology. It's all three of those coming together, and bringing a book that hits on the technical parts, but also some of the people process parts. I know that's a really crucial, I think, component that you really hit on a lot in the book.
Yes. It's very clear that you can't solve scaling and availability by code. You can't solve it by just wishing it away. It's a combination of developers doing the right things, management doing the right things, putting processes in place and procedures in place in order to do the right things. And all of those things together really have to work as a cohesive whole in order for you to be able to build a system that's highly available and still being able to scale. Just as a simple example, we've talked about this topic a lot, Ken, but risk management. The ability to come up with and figure out what the risks of your application are in order to reduce availability risk to your application and to be able to scale. That's as much of a process issue as it is a technical issue. When you build technical debt into the application, dealing with that technical debt and understanding which of that technical debt that you need to remove versus live with, that's a process issue, not a technical issue. And putting all of those things into place requires, a whole cohesive process that's not just technology, not just management, not just engineering, not just IT. It involves everybody working together to make that happen, and across all the different disciplines that are important in building an application.
Yeah, Lee, let's double click for a moment on the risk matrix. I always think that's so interesting, because a lot of times people first go to a risk matrix and they say, okay, well, let me identify, what are the key risks to the business? Where are some things shaky? But it's a really powerful tool also to not only understand risk, but also understand where should you be making investment. You think about the amount of times that you and I have talked to large enterprises where maybe after a major outage or a major impact, then they came back and realized that maybe for years they had underinvested in that particular area because maybe it was running okay, but no one really had a risk matrix, a data point to show this area is risky. It makes sense to investment. So it's a great tool for even, I think, technology leaders to talk about investment with their business partners.
Absolutely. One of I think the under-recognized values of maintaining and building risk matrices is the ability to communicate with upper management. Nothing says, take a step back here. When your management comes to you and is frustrated because you're not getting the things done you need to get done, or they think that you need to get done, and you start talking to them about, well, we have all these other things we need to do, it's hard to explain and have the conversations to understand what's important and what's not when management wants new features and engineering wants to improve things and operations just wants things to work no matter what. And all of these different competing requirements can't be prioritized against each other. What the risk matrix does is it puts all of those things together into a single format, and it starts putting measures on these things. So you can tell that, not doing this capability is going to cost us this amount later on because of this risk that's going along with it. And by doing that, you can communicate both technical risk up, but also product risk down throughout the organization, and start being able to prioritize and make decisions a lot better on what things really are the most important things to work on first. And is it more important to remove this technical debt or add this new feature? What's really more important, and how do you make those decisions? A risk matrix can really help you accomplish that.
No, I love in the book how you really emphasize that, and it really allows people to really take the term, technical debt, and again, translate it into risk, or business terms, because no business leader, when you just like, hey, we have technical debt, that's usually like, hey, you're just looking for more investment. But when you can talk on these other terms, it helps a lot. One of the things I really like in the book is it's not just you give the framework of how you set it up, but you actually give people actionable examples that they can actually go to your website and download templates, right?
That's correct. Yeah, I've there's 1,000 different ways to do a risk matrix. I have a model that I prefer. I know you have a model that you prefer. I make those available in just a simple Excel spreadsheet format, available from my website. You can download and get to. And if you go to leeatchison.com, you can get access to those there. You can also get access to them, I believe, from O'Reilly as well. But there's nothing magic about it. It's not like you have to use a particular format or it won't work, or you have to do this, that, and the other thing and it won't work. But knowing where to start and having an idea of where to start can be a great way to synergize your organization. I've seen companies that have taken that initial format and said, well, this just isn't going to work at all. But they took it and started with it. And what they ended up with was something that looks completely different. And I have a hard time recognizing it. But you can still see it's a risk matrix, but it has the things that they care about the most built into it. It's not just likelihood and severity, which are the two things that I focus on primarily in the risk matrix, likelihood and severity. But they've also included things like revenue impact and how does this, what is the revenue impact for doing or not doing this particular item within the risk matrix? And, it's like, it's a step further, it's a step deeper into their processes that works for them, and it's great. But they started with the initial idea of the risk matrix, took the initial templates and built on it from there.
Let's talk a little bit, like you mentioned with New Relic, deconstructing the monolith into microservices. And, I think companies that are building new, oftentimes they're starting with microservices. So I want to hit on that too. But let's talk about companies that maybe still have some monoliths. They're moving to microservices and trying to go to a services architecture and thinking about SLOs and SLIs. You have a lot of great information in the book about kind of going through that transformation. Can you talk about what are some of kind of the key takeaways that companies should consider that they can uncover in the book?
Sure. And a lot of the devil's in the details. I say there's a fear from many people of moving monoliths to microservices, and the main fear is around past experiences that haven't gone so well. And so if you look at the things that have gone, that can go wrong in that sort of transformation, there are a few things that are kind of common that appear that people can, always run into. And by dealing with them up front, you end up in much better shape as time goes on. One of the big ones is, well, where do I want to put my service boundaries? Do I split this monolith into 5 services or 500 services? What's the right size and the right model for that to work? And it turns out there's a lot that's involved in deciding where you want to put a service boundary. And I have a whole process I go through for right sizing microservices, if you will. I call it the Goldilocks process. It's not too small or too big. It's just right. And it's all about, the structure of the data, the structure of the code, the size of the team it takes to support the code, and how you build and make that model work as you go along. And it's too much to probably get involved in this level of conversation, but there's a lot of information there and a lot of articles I've written on this topic as well too, that talk through the process of how do you decide where to put a boundary into your microservice. That's number one. I think number two, and in many ways, maybe this is number one, is knowing when to stop and when not to stop. I've run into many, many, many companies that have started down the process of building microservices and stopped it halfway in the middle. And this isn't just true with microservices. I've seen it with other migrations as well, cloud migrations, other things. But what they do is they find that it's the cost is higher than expected, the difficulty is higher than expected. So they start down the process and then they stop. But the problem is there's not a linear graph between the amount of effort you put into a migration and how much benefit you get out of it. What happens is when you put effort into a migration, at first you get negative benefit out of it because you kind of go into this trough where things are actually worse for your application than they were before. You've got a monolith that's broken into 10 parts that are all intertwined in weird ways. And it's a more complex and more difficult to manage situation. But then you get to a point where as you keep investing in the migration, you start seeing the benefits coming out of that migration, and you start seeing the benefits start outweighing the cost going in. And there's a translation point where the benefits outweigh the total cost that you put in, and that's when the migration is a success. But too many people run into that cost of the migration and are in the middle of that cost vector of the migration, and then decide it's too expensive, can't complete this, and they stop in the middle. And what they've done is they've gone to the point where they've invested money that's wasted, and they've made the application and the technical debt in the application worse. These things are worse now than they were before. I've even seen companies stop at that point and then try and convince everyone that this was a success. We proved this was a hard exercise, so we got good learnings out of this. And so therefore things are better off because of it. But everyone looking at the mess of code that's available to them says, there's nothing better about this. I mean, this is the bad situation we're in. But they stopped investing. So the second piece of advice is commit to it and commit to completion. Because there are going to be low points. There's going to be points in it where you're convinced it's not going to work. Trust the process and realize that it will work and it will complete. And maybe it'll be more expensive than you initially thought. That does happen sometimes. But you'll come up with a better world when you're finally done.
Is there any, I think I know the answer, but is there any key trends that you see of the people who went all the way and the people who kind of stopped in the middle? Like, is there any secret sauce that if you don't do this, you won't get to the other end?
Yeah, absolutely. Planning is key. So knowing what you want to do and how you want to do it is critical. When we're talking specifically about a microservice architecture, deciding which direction you're going to go, where you're going to start at the bottom and move up or the top and move down is critical. I usually prefer the bottom up, so start with critical components like user identity and things like that, and then build on top of that versus starting at the user experience and moving down. Having a plan for which direction you want to go and what the steps along the way are. Dealing with the process changes that are going to be required to make this happen as you go along is also critical. Things like CI/CD processes are nice to have for monoliths. They're absolutely essential for microservice architectures. So building those in place before you need them is a critical aspect. Focusing on those process and procedure improvements as you go. And I think, the biggest thing is understand it's an investment. It's taking time away from building new features, yes, but it's the end result when you're finally done is you're going to be in a better situation and being able to better respond to faster moving trends in general. And that's going to make you more responsive and being able to build a better business. But you don't get there overnight.
No, I think that makes sense. I think you and I have talked about this. I think making sure the business comes along for the ride and they understand the business benefits, like business agility. You just hit on that. I think so spot on. Yeah.
When I was at Amazon, the very first project I ever worked on was moving from the Obidos monolithic Amazon.com website into their service-oriented architecture, and I was one of the managers that drove that migration project. And the level of, that project worked. It was successful, and the end result was, the things we were able to work on in the future grew astronomically as a result of that migration. You could just see it on the website when you would go from slow moving new features being added occasionally, but not very often. Then we invested in the migration, and no new features appeared on the website for a long time, a year and a half, or not much new stuff appeared. And then finally we finished, and a pent-up demand of all these new capabilities and new trials and tests just magically started appearing and started growing, within the organization and visible to the outside world in a very, very, very fast manner. And that innovation, that growth, was only possible because of that investment we put in to do the migration. And the level of management support necessary to do that was huge, because the cost of not innovating for a period of time was extremely high for a company like Amazon, but they saw the investment and they made it work. And this had support all the way up to Jeff Bezos. I mean, Jeff Bezos was involved and knew about the migration going on. And I have had conversations with him about it as we were going through the migration process. And he was one of the first people when we finished the project. He came down at our launch process and thanked us for all of our work. So this had huge management support from the very top of the organization down to make these changes. And these changes were fundamental to allow the retail organization to continue to innovate and grow and to come up with new ideas as time went on.
I love that the business leader getting involved, and supporting the team. I think that's so critical. I always think about whenever you share some of your Amazon, and you're usually not quick to share this, but thanks for bringing Beanstalk to the world. I know so many companies use that every single day, and that must feel great, bringing that. Do you actually mention that in the book? I can't remember. I'm
not sure if I mentioned Beanstalk in the book or not, but I'll tell you, if people don't know when we're recording this, but AWS reInvent is going on as we speak right now as we're recording this. And just yesterday was Adam Selipsky's first keynote presentation, and he was my manager for Beanstalk, and he's now running AWS. And one of the, he went through a 15-year history of AWS, and the early history, you mentioned, S3, EC2, RDS, and Beanstalk. And it's like to hear Elastic Beanstalk mentioned on that stage was kind of a neat feeling, because that was my baby. That was the thing that they brought me in to help build that product. And what was really innovative about Beanstalk, it really isn't a complex service, but what it was Amazon's or AWS's first platform as a service versus infrastructure as a service. And what it did is it took the existing infrastructure services that were there, which were just a handful of services at the time, and it put a wrapper around them in a way that provided a business value to customers. So instead of having, compute EC2 units and storage units and a database and just all these random components, you had a web application. And you could take a web application and install it, and we would do all of the infrastructure for you to make all that work. And that was a really innovative service at the time, because it was the first one that did that. Now, a company like AWS has 200-300 services. Most of them are platform level or application level capabilities. But at the time, that was really innovative. It was a different direction for AWS to go. And it was great to see that mentioned during the keynote.
And Lee, a lot of people read your book and reach out. I think you work with a lot of companies now, kind of helping them on these journeys after they've read the book. What are some of the key things where someone read something in the book and is looking, kind of looks to you to kind of go that extra detail of how do you implement the concept? What are the kind of the key themes that you see people reaching out and asking to you where they kind of learned about it in the book?
I'll tell you, one of the most common things I do with clients is I'll do a survey of their processes, their procedures, and less so their code, but their the architecture of the application, and tell them, here are places you're going to run into problems. Here are places that are causing you problems today, whether you're aware of them or not. In some cases they are aware, in some cases they're not. But it's sometimes it's just hearing an outsider come in and say, yeah, this is, where the problem is. It's right here. And their response to say, Yeah, but it's great to hear that someone else agrees with that, or someone who knows what they're talking about agrees with that. And that's what we thought would be the issue. That alone is extremely valuable. So I would say I spend most of my consulting time doing that sort of analysis. It's like, just give me, let me spend a few days talking to your engineers and your organization, and come up with a list, if you will, or a recommendation of where you really should focus on in order to improve availability and scalability in particular, but also general modernization and to increase flexibility and growth and all those sorts of things. And often the results of that are things that you kind of already know are true, but hearing it is good confirmation. And almost exclusively, when I've been able to do that successfully, companies have come back and said, yep, that's changed the direction that were moving. And we took what you said to light. We've even changed staffing as a result of some of my decisions, and helped to put a better procedures and processes in place in order to do the right changes, to get rid of the technical debt and to make things go in the right direction. As far as specific tools that are helpful, the risk matrix is probably the number one most important tool that people take from my book, and I'll talk about in my consulting, and they'll take that and grow with it. The second one is moving to microservices and plans to make that happen. Third is probably data management and data sizing and data construction. A lot of people are still falling into traps of having your database doing too much work. Let's put all of our data into a single database, then use complex database constructs in order to pull out the data we need as we need them, versus localizing data where it's needed, making data part of the service. And so you deconstruct your data just like you deconstruct your service code. And so you have data that's much more manageable that way in a much larger organization. Those sorts of things are probably the biggest things that people take out of what they get out of my book anyway.
That makes a lot of sense. If you could, I know we talk about architecting for scale, but maybe you also talk a little bit about operating for scale, like service level objectives, error budgets. What are some of the key takeaways when you start building a system that's going to operate at scale that you need to make sure to implement? Yeah,
I think the biggest one, I always say that availability and scalability are the same thing. And I firmly believe that, because what usually happens is as you scale, your availability suffers. And as you build an application that has more and more customers, you end up making decisions that impact availability more than necessarily, and that has an impact on scalability. So often when I'm talking about the operational aspect of things, I'm focused more on the availability aspects than on the scalability access. So things like zero downtime deployments, things like the security processes to keep bad actors out. I'm not a security expert, but security processes and procedures are part of your risk management process. You have to inject them into that whole process as well. Things like, testing at scale. Believe it or not, I'm a firm believer that unit testing, code level testing is less critical than production testing. And I do most of my, at least this, as I recommend to my clients, what I recommend to them is to spend most of their time testing with full production in a production environment. Game days. What happens if I pull a data center offline in production? Do things just continue to work, or do they break? What happens if I randomly crash computers 1 hour across my data center? What happens? Doing that sort of testing and random testing, doing that in production not in a staging environment, not in a desktop, but in a production environment. The net result of doing those sorts of things is you end up with a much higher reliability system and a greater trained staff to be able to deal with problems as they crop up. And the cost to, in the initial days of, what happens when I turn off a computer? Well, my whole system goes down. Those days do happen at the beginning, but the cost of that is insignificant compared to the savings later when you get to the point where random problems occur that you're not planning on, and your system's able to self-heal and self-recover from them. Self-healing is a big aspect of the things I teach from the coding aspects, and they play into the operational aspects. So I'm a huge fan of production level, game day sort of testing, and that being the most valuable testing you do to your system. I hear people focus on test suites. You can't release code unless you write an extensive test suite that goes with that code. Well, most of the time I can say I don't care whether you write test suites or not, because for the most part, most of the time, the types of bugs that are hard to find, hard to identify, and cost your business money aren't the bugs that are caught by a developer level test suite. They're the bugs caught by production operational environments.
Now, I hit on a couple of things. I think, when you're going to services, making sure you have defined inputs and outputs and really have the monitoring and on that level necessarily versus just the code inside, because you might not catch things. But a lot of people, I think, might confuse game days with a DR exercise, because I know, we've talked to many large enterprises, and a lot of times the quote DR, or they might mix up with the game day, is really a tabletop exercise versus a true game day. Can you kind of share the differences from your perspective on what a true game day and when you're running game days in your organization versus a DR exercise versus a DR tabletop exercise?
Sure. So, literally when you are running your application in production, turning off production level resources or causing them to behave inappropriately and just seeing what happens without telling people that you're going to do this, without giving heads up to your development organization. That is what I mean by game day. Has nothing to do with the formal process of disaster recovery. You can have all the paper plans in the world for what to do when your system fails, and we're going to roll over to this environment, and we have these level of backups, and all these things work fine. And on paper, they can work fine. In reality, they don't. And nothing beats being prepared for a catastrophe than causing a catastrophe to see what happens. And it sounds crazy to be thinking about this, but boy, I would much rather see what happens when I completely destroy a data center during the day when my staff is around and perhaps at a low traffic time for my website or lower traffic time for my website. I'd much rather do that than to have it happen in the middle of the night when my on-call engineer is just waking up from going to bed 2 hours ago and is still groggy, and all of my customers are complaining. I would much rather have the former than the latter. And so I want to make sure that everything works by testing that it actually works, as opposed to doing the paper exercise to see whether it works. And so disaster recovery planning scenarios that you typically get from, here's my DR report, so I'm covered. That paper is worth the price of the paper it's written on, and that's really about it. Because unless you are certain that things are going to work in a scenario by testing it, it's an irrelevant sheet of paper. So many times I've seen disaster recovery scenarios fail because somebody forgot something. One of the stories I tell in my book, and I tell the story a lot in my talks, is I tell the story about an apartment, living in an apartment and having a garage in that apartment. Now, this apartment that I'm living in has poor quality power, and so I buy a generator that I can use when the power goes out. And this is part of my disaster planning scenario. When the power goes out, I have a generator. I can still keep my refrigerator working and I don't lose food. So when I don't need it, though, I put the generator in the garage. The problem is the garage is one of these apartment garages with only the main door, one door. That's the only door into the garage. And it's got a garage door opener on it. And nobody thought to put in a mechanical release lever for this garage door opener that's accessible from the outside. So when the power goes out to the apartment complex, you can't open the garage door. So you have this generator to solve the problem when the power goes out, but you can't get access to the generator because the power's out. But you don't think of that until you actually go through the scenario of turning off the power, setting up the generator and seeing if it works. And then you see that, oops, there's a flaw in my plan here that doesn't work because I didn't think about how do I open a garage door when there's no power. That step in that process didn't enter the DR playbook, but you would notice it instantly when you try it out to see what actually happens. So I use that example a lot. It's a great example of multiple levels of problems that when it's most of the time when you have a major outage, it's not one thing that went wrong. It's 2 or 3 or 4 things in a row that goes wrong. Disaster recovery plans tell you what happens when one thing goes wrong. So when the power goes out, do this. That's great. When such and such happens, do this. That's great. But they don't talk about what happens when cascade things occur. So in this example, there's 2 problems that occurred. Power went out, and nobody thought about what would happen to the garage door when the power went out. So that combination of those 2 mistakes together meant that you had a disaster recovery plan that was inaccessible to you.
Yeah. I always think big outages are always if. It's like 3 things happened and then you have a big issue. I love how you also talk about, there's terms like chaos monkey, but actually building in your systems chaos. So it's constantly running, which really forces that constant, focus on resiliency by design.
Yeah, absolutely. Thank you for mentioning Chaos Monkey. The whole idea of having a production environment that is chaotic and filled with unexpected things happening is valuable, not a problem. So people say, I want my production to run smooth. No, you don't. You want it to run as chaotically as possible so that as many things that could go wrong happen. So you build the processes in to be able to respond to them so that when they happen and you're not expecting them, you're able to self-heal and self-recover from them. If you have a solid continuous deployment process with the solid ability to back out of a problem very, very quickly and roll back, with ability to quickly respond and get a new capability out quickly. An outage doesn't have to be a disaster. It doesn't have to require, if you make a mistake in the code and it causes a feature to disappear, well, you roll it back and fix that problem quickly. And you'll know never to do that change again, right? There are all sorts of things you can do that create that cause a chaotic production environment. And you need to be able to build defensively code that can live in that environment. And very quickly, if you build code that isn't defensive enough to live in this chaotic environment, you'll learn very quickly the moment you deploy it that there's a problem with it very, very quickly, because you're going to hit those corner chaotic cases that are causing these problems very, very fast. And so you tend to produce higher quality code, higher quality releases, more responsive releases, more self-healing releases over time by having a chaotic production environment. When you don't have a chaotic production environment, when you have a smoothly operating production environment, you get complacent and you start assuming things are always going to be smooth and operate normally, so that when a problem occurs, it becomes a bigger problem, a much more serious problem.
Lee, in prior lives, we both run systems that, half-hour outage is $40 million, high pressure. Yeah. I always think about when you build chaos into your system, like that gives you peace of mind because the system's constantly under your attack that you created, and it's resilient by design. So I always think like that gives the team a peace of mind where you're going to have less issues by making that investment, which means less late night calls, means less, high priority RCA reports and all of that, less DNR plans, all that good stuff.
Exactly. Yeah. Chaos shouldn't be feared. Chaos is value. Chaos is learning, is examples to learn. And the more chaos you have, the more you learn, the more capable your system is, the more robust your system is, the more stable it's going to be as time goes on. If your application can run in a chaotic environment, it can run anywhere. If it can run in a smooth environment only, it can only run in a smooth environment.
But Lee, there's so many other things that you can learn and unpack in architecting for scale. I know we don't have that much more time. Anything else that you think we should bring up that, might be a tidbit that a reader can just take and run with and get some value right away?
Oh, geez. We've talked about risk management. We've talked about chaos learning. We haven't talked too much about CI/CD, but it should be obvious from what we're talking about here that a high quality continuous deployment, continuous integration environment is critical to running a chaotic production environment that's highly available and highly scale. Companies like Amazon do hundreds and thousands of releases an hour. And there are still customers today, or clients today I've dealt with. I have one client in particular I was talking to not that long ago that is still tied into the weekly release process. And their weekly release process, they'll release every Thursday, whether they need to or not, something. And guess what? Those releases are costly. They're problematic. They're undisciplined because they only occur every week, but when you're releasing continuously, hundreds of times a day, then the release process is just an extension of the development process, and you're able to respond and fix things a lot faster. So we didn't talk too much about that, but I would say that would be one more thing I would throw into that mix. And make sure that you understand is that process, the CI/CD process, is absolutely essential to maintaining a robust, chaotic environment.
I agree. And I think that's also a good point, as you talked about making the full switch to services. Because if you're deploying a monolith still, or a hybrid Frankenstein monolith where you half went to services, it's really hard to have like canary deploys or things that are checking and saying that this thing is functioning correctly. And so it really, I think, limits companies' ability to have those continuous deployments, the bigger, uglier, bulkier the system is. So I think to me, it's just a great point of why they need to follow through.
Yep. Yes, exactly. Yeah, it's, that you're right. That's one of the common feedbacks with CI/CD systems is I can't deploy my monolith that fast. It just takes so much effort to do it. I can't automate it because it takes 30 people touching these 20 files all at the same time to make it work. Well, that's the problem then.
I agree. And maybe it's so complex that even if I did automate all those things, I don't know for sure if a particular thing was broken. But like in your book, if you have services and they're discrete and they're sized the right way, you know what they're supposed to do. So you know if they're functioning or not. And so you can kind of release without fear.
Yep, absolutely.
I think that's a really, really good point. Well, Lee, I'm so excited in your next event. Obviously, do you have any more books coming out soon, or?
Stay tuned. Yeah, I've got a couple in process. I've been talking to publishers, but nothing I can easily talk about right now. But stay tuned. There is more coming. But definitely look at my website. Besides my main book, I have a couple of I've got articles in other O'Reilly books and a couple of reports written that are part of the O'Reilly ecosystem. And I have a book that I wrote for Redis Labs that on caching that they give away to their customers. And so take a look at that. So I've got several books out there. Certainly Architecting for Scale is my main one, but there's going to be a couple ideas in the works here. There'll be another big one coming out here. If not next year, then very early the year after.
And Lee, if companies are kind of on that journey, on that mission transformation, they can go to leeatchison.com and learn more. And not only will you help them, but you also want you to like even come with the keynote to explain the benefits, to the organization, to the tech group. You still do that too, right?
Absolutely. Yeah, I can, if you just from the content that I write, that can be helpful to you. But if you want to engage me more directly, I can come in, I can give a presentation to your team. I can, do, an educational webinar or a seminar to your team, or I can do one of these analyze and comment and make recommendation processes, which is a little bit deeper integration. Or I can do more than that. It all depends on what you're looking for. But absolutely, I just gave a keynote last week to a company that was going through launching a whole new availability project, a little bit more than a project, and a program that they're working on, and brought me in to talk about availability for my book. And I do those sorts of things all the time.
All right, Lee, it was great catching up. Look forward to our future videos. I know we always love to catch up, but if you haven't seen it yet, definitely pick up Architecting for Scale. I have it in my book right behind me, and especially the second edition. So good stuff, Lee. Great talking to you.
Thank you, Ken. Great talking to you, and we'll talk to you soon.
Thanks for listening to this episode of the GOTO Podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.